Hello friends, myself Piyush Lokhande and I am from IIPS DAV and today I am solving the third internal test paper of computer oriented numerical method. And our first question is obtain the Simpson's 1 by 3 rule from Newton's Cotes formula. So Newton's Cotes formula is I equals to NH I equals to 0 summation n yi NCI. Here NCI is Newton's Cotes number and its formula is NCI equals to 1 upon n 0 to n Li u du. Now we can find Simpson's 1 by 3 by putting n equals to 2 in Newton's Cotes formula. So when we put n equals to 2 in Newton's Cotes formula, we get I equals to 2h I equals to 0 summation 2 yi to ci. Now we will open this summation I equals to 0 to 2. Then we get y0 2c0 plus y1 2c1 plus y2 2c2 and we will name this equation number 1. Now we will find 2c0, 2c1 and 2c2 by the help of Newton's Cotes number formula, which is NCI equals to 1 upon n integral 0 to n Liu du. So first we will find 2c0. Here n is 2 and 0 is I. When we put this in this formula, these values, we get 1 by 2 0 to 2 integral u minus 1 u minus 2 upon 0 minus 1 0 minus 2 du. On solving these terms, we get u square minus 3u plus 2 upon 2 du. And this 2 will be multiplied by this 2 and after integration with respect to u, we get u cube by 3 minus 3u square by 2 plus 2u and limits are from 0 to 2. When we put limits in this term, we get 8 by 3 minus 12 by 2 plus 4. And on solving this, we get 2c0 equals to 1 by 6. Now we will find for 2c1 and here n is 2 and I is 1. We will put in this formula and we get 1 by 2 integral 0 to 2 u into u minus 2 upon 1 minus 2 du. Now next term we when we multiply we get u square minus 2u upon minus 1 du. On integrating we get u square by 2 minus u cube by 3 and limits 0 to 2. On solving limits we get 4 by 6, which is the value of 2c1. Now we have to find 2c2, but we have one property which is NCI equals to NCn minus I. So 2c2, here n is 2 and I is 2. On solving we get 2c0, which is equal to 2c2, means value of 2c0 and 2c2 is equal, means 1 by 6. So we get all the values 2c0, 2c1 and 2c2. Now we will put in the equation number 1, which is this. So when we put this values, we get y0 1 by 6 plus y1 4 by 6 plus y2 1 by 6. On solving this term, we get I1 equals to h by 3, y0 plus 4y1 plus y2. And our general formula for Simpson's 1 by 3 is In equals to h by 3 under bracket y0 plus yn, which is first and last term, plus 4 into y1 plus y3 plus y5, which is odd terms, plus 2y2 plus y4 plus y6, this is the even terms. Now this Simpson's 1 by 3 used when interval is even. Now our next question is obtain Simpson's 3 by 8 rule from General's quadrature formula. General's quadrature formula is I equals to h under bracket ny0 plus del y0 n square by 2 plus del square y0 upon 2 factorial in brackets n cube by 3 minus n square by 2 plus dash dash dash. On putting n equals to 3 in this quadrature formula, we can find the Simpson's 3 by 8 rule. On solving this and putting n equals to 3, we get h 3y0 plus del y0 9 by 2 plus del square y0 2 factorial 9 minus 9 by 2 plus del cube y0 upon 3 factorial in bracket 81 by 4 minus 18. Now we have to find del y0, del square y0 and del cube y0. Means del cube y0 means third forward difference of y0 and del square y0 means second forward difference of y0 and del y0 means first forward difference of y0. So this is the formula for that, and on putting these formulas in this equation we get this result, which is I equals to h under bracket 3y0 plus 9 by 2 y1 minus 9 by 2 y0 plus 9 by 4 y2 minus 9 by 2 y1 plus 9 by 4 y0 plus 3 by 8 y3 minus 9 by 8 y2 plus 9 by 8 y1 minus 3 by 8 y0. On solving these equations, we get our result I equals to 3h by 8 under bracket y0 plus 3y1 plus 3y2 plus 1 by 8 y3. And the general formula is in equals to 3h upon 8 under bracket y0 plus yn plus 3 into y1 plus y2 plus dash 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 and 2 into y3 plus y6 plus dash dash dash. Here y3 y6 are the multiple terms of 3 and here are remaining terms. Now our next question is uh, write algorithm for Runge kutta fourth order method. So Runge kutta fourth order method will start from first step, which is start, and second define the function f of x comma y. Third, read input x0 comma y0 h x. Here x0 and y0 are initial values, h is the difference and x the number which we have to find. Now we will calculate iteration, that how many times this will run. So n equals to x minus x0 upon h. Now we will use for loop I equals to 1 to I less than equal to n, and we will put formula for Runge kutta method, which is k1 equals to h f of x0 comma y0, k2 equals to h f of x0 plus h by 2 comma y0 plus k1 by 2, and k3 equals to h f of x0 plus h by 2 comma y0 plus k2 by 2, and k4 equals to h f of x0 plus h comma y0 plus k3. Now we will find the value of y0, and its formula is y0 equals to y0 plus 1 by 6 in bracket k1 plus 2 k2 plus 2 k3 plus k4 bracket close. Now we will increment the value of x, which is x0 equals to x0 plus h. Now we get the value of x and y. We have find the y value for this x. We will print this value, and our last step is end. So thank you friends. Please like, share and subscribe.